For the following exercise, solve the quadratic equation by factoring. Now, certainly, we could use factoring in this particular case, and it really wouldn't be that bad. In order to do the factoring process, we need everything to one side of the equation and have it set equal to 0. Notice here I now have the difference of squares, because 9x squared could be rewritten as 3x quantity squared, then 25 is a perfect square as well. So this would factor into 3x minus 5 times 3x plus 5. Once those are both set to 0, I would have 3x minus 5 equals 0, 3x plus 5 equals 0, and the solutions to these two linears would now give me the solution to the problem. So add 5 here, 3x equals 5, or x equals 5/3, and 3x equals -5, or x equals -5/3. Now, I don't particularly think that's the easiest way of solving this particular problem. An alternate way is this. If you notice that there's no linear coefficient here, so there's nothing like plus 4x, for instance. So there's no linear variable, which means we can use the square root property. So the square root property would say, instead of giving every term to one side and have it set to 0, get all the constants combined on one side. So if I take 9x squared equals 25 and divide both sides by 9, then I have x squared equals 25/9. Now, you can take the square root of both sides, and because we're taking the square root of a squared variable, we would need to consider the positive and negative case over here, so that x equals the plus or minus. Now, when you take the square root of a fraction, just take the square root of the numerator and denominator separately. So this would be plus or minus 5/3, the same solutions that we got originally.